Alright, so we're looking at the second part of section 7.2. This is a little bit different than what's in the student journal, kind of close though. You're going to go over, scroll down to the third page where it starts with day 2, right here. And we want to go over some notes here about functions that are in a different form than what we're used to. All the functions we've been looking at have been in this y equals a over x minus h plus k form. We found out that the vertical asymptote is always x equals h, and the horizontal asymptote is always y equals k. Well, now we're going to talk about functions that are rational that are written in this form. Another thing to keep in mind is anytime we have these rational functions, they will never cross a vertical asymptote, but it can cross a horizontal asymptote. We're not going to be doing that yet, but we'll see tomorrow how that sometimes does happen. Another important part is that if we're given the equation in this form, we can quickly find the horizontal asymptote by just doing y equals a over c. So it's the coefficient of x here in the numerator divided by the coefficient of x here in the denominator. Y equals that value will always be the horizontal asymptote. We could also find that horizontal asymptote by using long division or by taking this and getting it into this form. We're going to look at both ways of doing that. And whenever we want to find the vertical asymptote, we set that denominator equal to 0. So we're going to start by just practicing putting these functions in this form. All right, so let's look at this first example. We want to get this into that form. So what I want to do is I want to think about how if I had the problem, let's say 1 plus 2 over 5. If I have 1 plus 2 over 5, that answer is 3/5. I also, though, could have thought of this as 1/5 plus 2/5. See how I can split that up? 1/5 plus 2/5 would still give me 3/5. When I have addition or subtraction in that numerator, I'm allowed to split it up. That's what we're doing when we do this kind of process. So what I want is I want to have x minus 2. I want to be able to split it up so that I have an x minus 2 in the numerator because I want it to cancel out. But in order to have that happen, I have to keep it equal. So if I write x minus 2, what would I have to do to that to keep it equal to x plus 3? If I have x minus 2, how can I keep it equivalent to x plus 3? What would I have to put? If I want to have positive 3 instead of negative 2, what would I have to do, Michael?
Plus 5.
Plus 5. So now I want to see, is this equivalent to what I started with? Is x minus 2 plus 5 the same thing as x plus 3? Yes? Then I'm allowed to do that. That is the same thing as what I started with. So I'm allowed to write it that way. Now I can split it apart. I can put x minus 2 all over x minus 2 plus 5 over x minus 2. See, I can split it up however I want. I could have just put x over this and 2 over this and 5 over this, but it's better this way because I'm trying to get a k value. So now if I have x minus 2 over x minus 2, that's just going to be 1. So now finally getting it into that form, it's going to be y equals 5 over x minus 2 plus 1. Another way to write this would be that. This is the same thing as that. Okay? So now I could see that I have a vertical asymptote at 2. I have a horizontal asymptote of y equals 1. And we also had a vertical stretch of 5 from that basic function that we started with of 1 over x. All right, let's try the next one. Okay, so if I look at this, this is 2x plus 3 over 5 parentheses x minus 2. Again, I need to get something so that x minus 2 would cancel. Let's say I add 5. What would I end up with if I add 5 here? What would this be equivalent to? 2 parentheses x plus, it would be 2x plus 8, right? Yeah, and would I be able to cancel? No, I wouldn't. I want to be able to cancel. So I want to have 2x. How could I factor out a 2 and then still get an x minus 2 to cancel? What would I need it to be? 2x minus 4. That's what I need, isn't it? This is what I'm going for, is 2x minus 4. So I need something equivalent, but I need to get a 2x minus 4. So watch what we do. We're going to say we need a 2x minus 4 over all of this. But I have to keep it equivalent. I want 2x minus 4, but I have to keep it equivalent to 2x plus 3. What do I have to do to this to keep it really equal to 2x plus 3? What do you do to negative 4 to get plus 3? Add 7. And now check it. 2x plus 3. Okay, it's the same as what I started with, so we're good. So now I can split it up. I can split it up like this. So I can say this is equal to 2x minus 4 over 5 times x minus 2 plus 7 over 5 times x minus 2. See, the denominator has to stay the same, but I could split up that numerator just like I showed you over here. The denominator had to stay the same, but I could split up that numerator. Yeah, can you send them down about half an hour? Yes. Today's the last day. Yeah. Bye. Okay, so we've got this. So now we want to get this simplified. So I'm going to have y equals 2 parentheses x minus 2. All right, so see now how these would cancel? So another name for this would be then, I'm going to put this one first because we always want to have that one first. And now we would have it in that form that we need. Now that was kind of difficult though, wasn't it? That was pretty challenging. The only reason we care about getting it into this form is because then we can see that we have a horizontal asymptote of y equals 2/5. We have a vertical asymptote of x equals whatever makes, oops, sorry, no, that canceled. Looking at this would be x equals 2 would be our vertical asymptote. Because it's whatever makes that undefined. That's going to be the vertical asymptote. That's the only reason really for doing this. But look at what it says up here. If we have it in this form, y equals a over c is the horizontal asymptote. Could I have just gotten that horizontal asymptote by just doing 2/5? Isn't that what it was? See how that's a lot easier to find the horizontal asymptote that way? And the vertical asymptote, I just would look at this and I would say, what makes that equal 0? And we would get x equals 2. So really, all of this is not necessary if we have a difficult problem, because we can just use these rules. So when it's a difficult problem, we're going to use this rule and we're going to use this rule. This one up here to find the horizontal asymptote, this one down here to find the vertical asymptote, because that's going to be a lot faster. All right, let's go down here now. So in exercise 5, we're going to go ahead and get this one into that form because it's easy to do. See how the coefficients are 1 and 1? It's easy to put it into this form. So we're going to have g equals, I already have x minus 5, so I want to have x minus 5 on top. So what are we going to have to do to keep this the same as x plus 2? What do I have to do? What do I have to add or subtract to keep it equivalent to x plus 2? So I'm going to add 7. Okay, now I check. Yep, that's the same. So now I'm going to split it apart. So it's going to be x minus 5 over x minus 5 plus 7 over x minus 5. So that's going to be the same as, I'm going to put this one first, 7 over x minus 5 plus 1. That's our function in that form. So now we're going to go through and find everything. What's the vertical asymptote? What's the shift here? What, guys? What's the vertical asymptote? X equals 5. The horizontal asymptote, that's going to be just this k value. So what's it going to be? Y equals 1. All right, so since I need to get x equals 5, I'm going to put my axis over here further. All right, so x equals 5 is right there. Y equals 1 is right there. So we can see those axes better. All right, so now we're trying to graph. So this was our shift right here. So now we're kind of looking at this as almost being our new axis. Now, rather than just finding random points, I want you to find the X-Intercept. Does anybody remember how we find the X-Intercept? Plug in 0 for, not X, Y. Plug in 0 for Y. See, the X-Intercept is where it crosses the X-axis. So see how Y is going to be 0 anywhere on that X-axis? So we plug in 0 for Y. So watch, here's how we find the X-Intercept. Plug in 0 for Y. What is 0 over? 1. 0 is always over 1. It can actually be over any number, but it's just easiest to put it over 1. We're going to cross multiply. We get x plus 2 equals 0. 0 times anything is 0. So what's that going to be then? X equals what? Negative 2. So our X-intercept then is going to be at negative 2, 0. So I'm going to plot that point. Here's my regular axis. I have the point negative 2, 0. Right there is one of my points. Okay, now I'm going to find the Y-intercept. To find the Y-intercept, I'm going to plug in 0 for x. If I plug in 0 for x, I'm going to get 0 plus 2 over 0 minus 5. What's that going to be then? If I plug in 0 for x, what do I get? Negative 2/5. So my Y-intercept then is 0, negative 2/5. So I'm going to plot that over 0 down 2/5. And now I know that I'm not going to cross this, I'm not going to cross this. So my graph is going to look something like that. Okay? And once I have these points, then I know that it has to be symmetric up here. So this one would look, I'm just going to kind of try to estimate that distance there. That's going to look something like that. Because it has to be symmetric about that point. That may be a little too far, but you get the idea. All right, any questions there? Now, looking back here, guys, remember the new way we can find that horizontal asymptote? I can just take these coefficients and divide them. See how quickly I could have gotten that y equals 1 that way? That would have been easier. The vertical asymptote is whatever makes this denominator 0. And see how that's 5? So we can quickly find those. All right, so rather than using this HK method on this one, we're just going to do it the way that we just talked about up above. So let's start off by finding the vertical asymptote. What would make the denominator 0? That's the vertical asymptote. Anybody know? 4, good. So my vertical asymptote is x equals 4. The horizontal asymptote, we look at those coefficients of x, and we divide them. Does anybody know what the horizontal asymptote would be? Y equals 2/3 is right. Okay, so now I'm going to start graphing. I'm going to put in my axis. I have to graph x equals 4, so again I'm going to put my normal axis over here a little bit. So there's my xy axis. I'm going to put in x equals 4. I'm going to put in y equals 2/3. Okay, and now I'm going to find some points. And the best points to find are those intercepts. So we're going to go ahead and find those intercepts. I'm going to find that X-intercept. To do that, I plug in 0 for y and solve for x. So I'm going to plug in 0 right here, and it's 0 over 1. And I'm going to cross multiply. So what's 0 times anything? So I have 0 equals, and then go this way, 2x plus 8. Can you solve that? What do you get? What's the x-intercept going to be, guys? -4. Okay, so we have that point, -4, 0. Over here. Okay, now I'm going to find my y-intercept. I'm going to plug in 0 for x. So plug in 0 for x. So that's going to be 0, and that's going to be 0. So then we're just left with 8 over -12. Well, I can divide those by 4, and I can get -2/3 for my y-intercept. So I go over 0 down 2/3. So it's going to look like that. All right, so now we need something symmetric to that. So look at this point right here. I have to go over and down, so I can go over and up. And so right about in there. And this point here was over quite a ways. So just kind of trying to make it look symmetric. Or you could literally plug in points if you needed to. Okay? Really, guys, all I'm looking for there is that it's a good reflection. That you have it in the right spot. Like if you put it down here, obviously that's wrong. But as long as it's in the right spot, I wouldn't be too picky about that. What about the domain and range here? Let's go ahead and write out the domain and range. Mia, do you have the domain?
Negative infinity to 5 or 4.
4.
And then union 4 to negative or positive infinity.
Good. So there's our domain. And then what about our range? Kayla, do you have the range?
Negative infinity to 2/3.
Great. All right. Makes sense there? So when we have these coefficients like this, it might be easier to skip that HK kind of method and just look at those coefficients and find the horizontal asymptote that way. We could have even done this one that way though. 1 divided by 1 is 1. That's what our horizontal asymptote was. The vertical asymptote is whatever makes that denominator 0. All right, guys, one more problem here. It's a word problem. So a 3D printer builds up layers of materials to make three-dimensional models. Each deposited layer bonds to the layer below it. A company decides to make small display models of engine components using a 3D printer. The printer costs $1,000. The material for each model costs $50. Find the equation to represent the average cost per model and graph it on the calculator. Okay, guys, do we know how many models we're making? No, so we're going to have to call that x. So x equals the number of models. We're going to have to start off by thinking of, when we're trying to find the average price for one model, we first of all have to think of the total cost. What's the total cost? What do we have to pay for the printer? $1,000. So I have to pay $1,000. Do I have to pay $1,000 times x, or just $1,000? Just 1,000. Plus, how much am I going to have to pay? 50x, right? $50 to buy the materials for each one of the models. That would be our total cost for all of the models. Because we had to buy the printer, then $50 for every model that we make. How would I find the average for each model, though? What would I divide by? Think about this, guys. If I wanted to find your guys' average test score, what would I do? Add up all your scores and then divide by what? The number of scores. So what am I going to divide this by? X, the number of models, right? So divide it by x. That's going to be the equation for the average cost per model. So it says to find that equation. And then it says estimate how many models must be printed for the average cost per model to fall to $90. Where would I plug in that $90? Do I plug it in for X or for A? A. I want the average cost to be 90. How do we solve something like that? You could put it into y equals. All right, let me go ahead and do it that way since that was the suggestion. Let's go to y equals. So I'm going to put in this price right here. I have to use parentheses because I want this entire thing. That's very important, guys. You have to use parentheses so that that entire thing gets divided by x. And then what do I want this to equal? What do I want it to equal, guys? 90, right? I want it to be 90. So I put in 90. If I go ahead and graph, I'm going to do a zoom 6 to graph. Here's the functions, and I'm not seeing anything. That's because I haven't set up my window correctly. What's the fewest number of models we could make? 0, really, right? We could make 0. And they're asking us, like, we don't know how many models we're going to make. Maybe it's 100. I'm going to go out to 100. Why is the average cost per model? Well, the minimum cost I could have would be 0, but I'll just leave that at -10. The maximum, I need to see 90. So what am I going to have to make this y max at least? 91. I'm going to go ahead and make it 200 just to make sure. So I see this part of the graph. And there's y equals 90. What would I be trying to solve for then? The point of what? Intersection. So I do second, trace, intersect. Get close to it. Enter, enter, enter. And I get 25. So, how many models? If we make 25 models, the average cost is $90. Would I have had to do that on the calculator? Nobody suggested how I could solve this, but I could solve that algebraically by just cross-multiplying. Do you guys see how we could have done that? We'd get 90x equals 1,000 plus 50x. Subtract this over, 40x equals 1,000. Divide by 40. and x would be 25, right? We don't have to use a calculator. All right, now the last thing. What happens to the average cost as more models are printed? All right, well, now I just want to get rid of this 90. Oh, shoot, just the 90. Let me type that in. Let me show you another way to type it in, actually. You guys, you have this fraction thing on here, too. If you go to, let's see, there it is. Okay. If you go to alpha F1, do you see how you have n over d? If you push that, it'll give you this fraction, and then you can type it in without using parentheses. Okay, so I just typed it in like that, just like it says. Now I don't have to use the parentheses because I wrote it in that fraction form. Again, how I got to that was alpha F1. Okay, and now I'm going to go ahead and graph. And here I'm just seeing that one part of this. The question is, as we make more and more models, what happens to the average price? Hit trace. Right here, the average price is $70. Look at the average price as we go down lower and lower and lower. I'd rather see this as a decimal, though. I'm just going to change mine because I want you to see the answers as decimals rather than fractions. So now watch as I hit trace again. This is telling me the average price. What do you think this average price is going to level out to? I'm looking at the y's as I make more and more. I'll just sit here and hold it until you figure it out. What do you think the average price is going to level down to? 50. Can somebody explain why? Okay, but there's another really good reason why. I want you to look back at this equation right here. Right here, actually. Tell me why this y is going to approach 50. Yeah, Emil. Perfect. That's our horizontal asymptote, isn't it? Remember how if you look at the coefficients of x and you divide them, that's going to tell you the horizontal asymptote? So that's what this is going to approach. As I go out here further and further and further, you could sit here and hold your finger here the whole entire period. Eventually, it's going to say 50, and it's not going to go any lower than 50. If I wanted to go out there and jump to a really large number, I could extend my x max. I'm going to make this a huge number, 999. Okay, so now I'm going to graph, and I'm going to test that number. It should be really close to 50. See, I can't test it until I set up my window to be able to test it. So I'm almost to 1,000,000. And look what it says. There's the average price, 50.0001. I said one too many zeros, I think. All right, got the idea? We're always going to approach that horizontal asymptote. All right, guys, that's it for today.